We are going to start incorporating some SAT questions. So to start today's lesson, we're going to go ahead and try one of these SAT questions. So I would like you to read through and answer the SAT question, and then after that we will go through the answer. All right, so we have on Saturday afternoon, Armand sent M text messages each hour for 5 hours. So he sent M text messages for 5 hours, and Tyrone sent P text messages for 4 hours. So which of the following represents the total number of messages sent? So total is going to tell us that we are adding these things together. So we are going to add what Armand did and what Tyrone did together to get our total. So Armand sent M text messages each hour for 5 hours. So for each hour, there was 5 of them. He sent however many messages. And we want to go ahead and add that to what Tyrone did, which would be 4 hours at P text messages per hour. So we should have 5M plus 4P. So that's going to give us an answer of C. So hopefully C was the answer that you chose. So now we're going to go ahead and get into today's lesson. And our goal today is to be able to identify key features of a polynomial, talking about degree, classification, leading coefficient, and constant terms, and then also multiply polynomials. So most of today should be review. Concepts that we covered in Algebra 1, but that are super important, so we're going to be going back over those today. So as we go through, make sure that we're taking notes and that we're working through the practice problems to kind of see where we're at with this material. To start, we're going to fill out this graphic organizer. So if you'd like to go ahead and copy this down, I would suggest pausing the video, jotting down this organizer in your notes, and then hitting play to go through and fill it out. So we are going to organize thoughts about what a polynomial is. So the first thing that we're going to talk about is, well, what's the definition? What is a polynomial? And a polynomial is a monomial or sum of monomials. So a monomial is ax to the b power. So that could be like 2x, 5x to the 4th, 6, 10x to the 3rd. Or we could then begin adding those together. We could have 10x to the 3rd plus 2x squared plus 5. That's what we're looking at for a polynomial. So things that we've seen before, we're just kind of putting a name to it. So like I said, this could be something like 5x squared, 10x to the 3rd plus 5. So a monomial or a sum of them. So what are some characteristics or facts about a polynomial? Well, one of the things that we're going to be discussing today and going through is that a polynomial has to be in standard form. And standard form means that we are listing our terms of monomials from highest degree to lowest degree. So listing terms from highest to lowest degree. Well, it's probably a good idea to know what degree means. So let's go ahead and define some key terms here. So 3 key terms we're going to talk about here are degree, lead coefficient, and constant. So let's talk about what degree is. Considering we just said standard form is highest to lowest degree. So a degree is essentially the variable of an exponent. There's the variable's exponent. The variable's exponent. So for example, if we had a term that was 5x to the fourth, the degree would be 4. So the degree is the variable's exponent. Now, to determine the degree of a polynomial, so let's go ahead and continue with that. So degree in general is just the exponent of a variable. Degree of a polynomial since that could be a bunch of terms added or subtracted together, is going to be the largest exponent, the highest exponent. And we'll look at some examples of this. So those two kind of go together. So degree is the exponent of a variable, where the degree of a polynomial is going to be the largest exponent out of any of the terms that you have. All right, so next we want to talk about, okay, what is a lead coefficient and what is a constant? So a lead coefficient is the constant of the highest degree. So remember, a coefficient is the number being multiplied by a variable. So 3x, the coefficient is 3. 10x to the fourth, the coefficient is 10. So the coefficient is the number in front. So the lead coefficient is going to be the number multiplied by the largest degree. And then the last thing we want to talk about is a constant, and a constant is just a fixed value. So it's just a number. It's not varying, so it doesn't have a variable. So a constant is a fixed value. So for example, 5, 10, 11, 6, -2. It's just a number. It doesn't vary, meaning it doesn't have a variable. So let's go ahead and look at an example. So if we had a polynomial, an example could be 3x to the fifth plus 2x to the third minus 4x plus 8. So this is in standard form because it goes from our largest exponent to our smallest. We go from exponent of 5 to 3 to 1 to 0. So it is in standard form. Now we're going to look at, okay, what is the degree? What is the lead coefficient? And what is our constant? So I've kind of got a little key going on down here. So it says circle the lead coefficient. So our lead coefficient is going to be 3. It is the number in front of the largest degree. The largest degree is 5 because that's our biggest exponent. And the coefficient of that term is 3. So that would be our lead coefficient. It leads off the polynomial. Box the constant. So our constant is going to be 8. It doesn't vary. It is fixed because it doesn't have a variable attached to it. It is just a number. So that would be a constant. And then the largest degree, or the degree of the polynomial, that is going to be 5. So this would be a 5th degree polynomial because that is our largest degree. So kind of a summary of what a polynomial is and what it consists of. So let's look at some examples on polynomials. All right, given 2x to the 4th minus 7x squared plus 3, we want to know what is the leading coefficient, the constant, and the degree of the function. So go ahead and copy down that polynomial, and then we're going to go through and answer these questions. So what is the lead coefficient? Well, this is in standard form because our exponents go 4, 2, 0. So they go in order. So our lead coefficient is the number in front of our largest exponent. So our lead coefficient is just going to be 2. Our constant is going to be the fixed value, whatever number that we're either adding or subtracting that doesn't have a variable attached. So that's just going to be 3. And then the degree of the function, well, that is going to be our largest exponent. So this would be a 4th degree polynomial. So this would be degree 4. So that's all we're looking for here. So adding one more component, one more example here, given 3x to the 3rd minus 8 plus 2x to the 4th, what is the function in standard form? And then continuing with the lead coefficient, constant, and degree. So remember, standard form is largest exponent to smallest. So we have an exponent of 4, 3, and 0. We don't have an exponent there. We're always going to end with the constant because it doesn't have an exponent. So standard form would be 2x to the 4th plus 3x cubed minus 8. That would be in standard form because it goes 4, 3, 0. So then looking at this, what is our lead coefficient? Well, it's the number in front of the largest exponent, so 2. What is the constant? It's going to be negative 8. And the degree of the function, our largest exponent, this is also going to be a 4th degree polynomial. So let's go ahead and take some time and give you guys a couple to work on here. All right, some practice for you. So create a degree 3 polynomial with a leading coefficient of 2 and a constant term of 7. So use our definitions to go ahead and do this, and then go ahead and answer the question. All right, next question. Is f of t equal t3 plus 5t to the 5th in standard form? Yes or no? And then think about justifying your answer. Why is it in standard form, or why is it not in standard form? And then go ahead and put your answer in. Okay, now we're going to get into the second half of our lesson, and this should be, for the most part, review. We're going to look at multiplying polynomials, and we're going to start by using the area model, which is just a tool that you can use when multiplying, and then we'll get into the more typical version of multiplying, but you can always refer back to this area model if it's something that you like. So why can we use an area model for multiplying? Well, if we think about what area is, it's base times height, or length times width, and so if we take what's on the length and we multiply it by what's on the width, we get the area, or what the two different polynomials are multiplied together. So it just kind of breaks it up into different parts, and it's more of a visual multiplication representation. So this says a rectangle has a height of 3x and a width of 2x minus 3. Express the area of the entire rectangle. So essentially we're just taking 3x times 2x minus 3, and we've got this area model set up nicely for us to go ahead and multiply. So what I'm going to do is I'm going to take 3x times 2x. So 3 times 2 is going to give us 6. It's going to give us 6. And then x times x is going to give us x squared, because x squared is x times x. It's 2 x's. And then we have 3x times negative 3. And 3 times negative 3 is negative 9. And we got to bring along that x. So the area would be 6x squared minus 9x. If you can think back to when we did multiplying before in Algebra 1, we were distributing. This is the same thing as distributing. I'm taking 3x times 2x and 3x times negative 3. I'm just distributing it in, and I'm multiplying. All right, so now I want you to go ahead and practice one. So I want you to find the area of a rectangle with a height of 2 and a width of 5x squared minus 2x plus 3. And then go ahead and put in that answer. All right, so hopefully you got the answer of 10x squared minus 4x plus 6. We just took 2 times 5x squared, 2 times negative 2x, and 2 times 3. You can kind of think about it as distributing to each of those terms. So those area models were multiplying a monomial by a different polynomial. So we were just multiplying one term into a polynomial. Now we're looking at multiplying binomials, which are two-term polynomials. So we want to express the area of this entire rectangle, and what we're multiplying here is x plus 4 times x plus 5. So essentially we have to take x times x, x times 5. 4 times x, 4 times 5. We have to multiply all of these terms together. So if we do this area model, we can break it down into the different terms and just multiply each one individually. So here up in the first box, we have x times x. Well, x times x is the same as x squared. So then if we go across, we have x times 4. So where they're matching up here, and that's going to be 4x. 5 times x, which is going to be 5x, and 5 times 4, which is going to be 20. So we want to find the area. So we have x squared, because we always want to write this in standard form. So we have x squared, because that's our largest exponent. But then we have two x terms. So whatever's on the diagonal is always going to get added together. So we have to combine these because they are like terms. So 4x plus 5x is going to give us 9x. And then 4 times 5 gave us 20. So that's going to be our constant term. So this here would be our area, or these two binomials or polynomials multiplied together. All right, now here's one for you to practice. So go ahead and copy this down and then go through and multiply it out, and then put in your answer to this question, and then we'll go through and check your work. So hopefully you can check your work and that you got the same thing of x squared plus 12x plus 35. If you didn't, go ahead and check your work and copy down the correct work so you have something to refer back to when you're doing your practice problems on Khan Academy later. So remember, we're just taking where these two things line up and multiply together. Then same thing across, we take x times 7x to get 7x, and then we have to go ahead and add the diagonals. All right, so the last thing we're going to look at is multiplying polynomials without an area model and how we can go ahead and do that if it's not asking us to find the area of a rectangle, but rather just multiply the polynomials together. So now we are just looking at expanding or multiplying, and our answer should be written as a polynomial in standard form. So that means we need to combine any like terms, and we do need to go from largest degree to smallest degree. So this is something that you've probably seen before. If you want to go ahead and make an area model, absolutely do that. That's a tool that you could use. So you could go ahead and go like this and say, okay, x minus 2 and x minus 6, and use that area model. But another way that you could go about doing this is essentially distributing, but distributing twice. So I have to take x times x and x times negative 6. So I'm just distributing in that x term. So when I do that, I have x times x, which is x squared, and x times negative 6, which is negative 6x. Well, then I have to remember I have to distribute in that second term because I have to multiply in the whole binomial. So now I'm taking negative 2 times x and negative 2 times negative 6. So that's going to give me negative 2x, and negative 2 times negative 6 is positive 12. Well, it is in standard form because it goes 2, 1, 1, 0 as my exponents. But I have two x terms, and in order to be in standard form, it does need to be one of each degree. So I do need to go ahead and combine those together. So I would end up with x squared minus 8x plus 12. So at this point, you could technically use either one of these methods. You could go ahead and do the area model, which you should see ends up with the same answer. You would just have x squared, negative 2x, negative 6x, and 12. Add up your diagonals, and you end up with the same thing. So whichever method works best for you, feel free to use when we are expanding or multiplying polynomials or binomials together. And again, one here for you to practice. So go ahead and write this down. Expand or multiply, either using the area model or like double distributing. And then find your answer or plug in your answer, and then we'll go through and check the work. So hopefully after going through and multiplying, you ended up with x squared minus 2x minus 15, because we ended up with a plus 3x and a minus 5x, and that's going to result in a negative 2x as our middle term there. And the last example that we're going to go through is still expanding, multiplying, writing our polynomial in standard form, but now we've just got some coefficients in front of our lead terms here. So it's still going to be that same process, and if you wanted to set up an area model, you could absolutely go ahead and do that, and I can kind of show you how to do that. So you would have 3k and negative 4, and you would have negative 5k and negative 8. And we could go ahead and multiply where each of those values come together, and you would still end up always adding up on those diagonals. Or we can go ahead and do the standard way of just distributing in. And when we do this, we have 3k minus 5k. 3 times negative 5 is going to give me negative 15. K times k is going to give me k squared. 3k times negative 8 is going to be negative 24k. And then we have to multiply in the 4. Well, rather the negative 4. So negative 4 times negative 5 is positive 20. Got to bring along that k. And negative 4 times negative 8 is going to be a positive 32. So make sure we're paying attention to those negatives. So we do end up having to add together our middle terms just like we add together those diagonals. And we end up with negative 15k squared minus 4k plus 32. So we just distributed in both terms. to the second binomial, and we added together the like terms, which is always going to be the middle terms, just like it would have been adding together those diagonals if you chose to do the area model. And your last practice problem, we want to go ahead and expand 2b plus 1 times negative b plus 7. So go ahead and multiply that out, either using an area model or distributing in, and then type in your answer, and then we'll go through and see how you did. So your final answer should be negative 2b squared plus 13b plus 7, because we end up adding together those middle terms and we get 14 minus b, so that's like 14 minus 1, which gives us a 13b. So go ahead and check your work. If you didn't get it correct, make sure to get the correct answer copied down as you're going to begin doing some practice. So go ahead and let me know how you're feeling with this stuff. So like I said, a lot of this is review. So before you even go in and start your practice, let me know how you're feeling. You feeling really good at a 4, or are you down at a 1, this doesn't make sense, or somewhere in between? All right, so to finish up today, you are going to complete the following in Khan Academy in your assignments tab. You have 5 assignments: polynomials intro, multiply monomials by polynomials, an area model, multiply binomials, area model, and then multiplying using whatever method you choose. And then you'll finish up with quiz number 1. Remember, that is worth more than a regular assignment, so do ensure that we do that. Feel free to do it as many times as you would like. Assignments must be completed at 70% or higher, so that would be that 1 through 5. Those must be done at 70% or higher. Essentially, you need to get 3 out of the 4 questions correct. So lastly, if you have any questions, please hop on Zoom, either 5th or 7th hour. I'm here to help, or feel free to just send me an email and I can try and get you more help if you need it, or answer any of the questions that you may have. So please make sure that we get this done in Khan Academy, because it's going to be worth a significant amount of points. It'll be worth about 12 points in the assignments category, and then a quiz grade as well. So let's make sure that we're getting those done. And if you have any questions, please send me an email or hop on Zoom.